Day 394 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 187, repeated DNA sequences. The difficulty level is medium, but you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. The DNA sequence is composed of a series of nucleotides abbreviated as A, C, G, and T. For example, the string ACGAATTCCG is a DNA sequence. When studying DNA, it is useful to identify repeated sequences within the DNA. Given a string S that represents a DNA sequence, return the 10-letter long sequences or substrings that occur more than once in a DNA molecule. You may return the answer in any order. All right, y'all, so that might seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure we're doing this problem correctly. Once we go through these examples, you'll see the question is not that difficult to understand at all. So let's see what example 1 says. In example 1, we have the input S equals a string A C C C C C A C C C C C C A G G G T T T. And then the output is an array of strings. Each string within this array of string is a 10-letter long or has 10 characters. The first one is AAAAACCCCC. The second one is CCCCCAAAA. So let's figure out how we got these two substrings or these two strings from this input, right? So what we're looking for is 10-letter long characters or sequences that occur more than once in the DNA molecule. This input represents the DNA molecule, so we want 10-letter long sequences that occur more than once. So as you can see, this is a 10-letter long sequence that occurs more than once in the input. It occurs once right here, boom. Then that same sequence occurs again once right here. Boom, so we can add that to our output because it's a 10-letter long sequence that appears more than once. Same with this sequence right here. This sequence right here appears once right here. Boom, then it appears again once right here. Boom. So we can add that to our array of 10-letter long sequences that appear more than once. Now let's go ahead and take a look at example 2. Example 2 is a little simpler because the whole input is just all string. Just all of the same character. So in the input S, we have the string A. Boom. The output is a string A. So that's the same string, or that's a 10-letter long subsequence that occurs in this string. Now let's see if this string is 10 letters, and I'll tell you why that's important after. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom. So as you can see, the input is more than 10 characters, but even though it's more than 10 characters, we only have one output, which is AAA. So it's not like we do this 10, then we start here and we do the next 10, then we start here and do the next 10. No, since this is the same characters and it would be the same string each time, we only have to say it once. We only have to return that string once. We don't have to return each one with just using a different A, like moving down the line, something like that. No, we just have to return it once because at the end of the day, it'll be the same string regardless. So since it's the same string, we only have to return it once. So now that we understand the question, y'all, let's get into the fun part, the actual solution. So first thing we're going to do is we're going to define the fixed length of the DNA subsequence that we're looking at. So for that, we could just say let sequence length equal 10, because that's the subsequence we're looking for. We're looking for a 10-letter long sequence. Then we're just gonna start a guard statement that will, for an early exit if the string is too short to contain the 10-letter sequence. So we just say guard s.count is greater than sequence length, else we could just open up the brackets and we could return a blank array. Start just like this. Boom. Then we need to convert the input string into an array of characters, which will help us with our slicing. So for that, we could say var DNA equals s.map, open up the brackets, we're going to say $0. This $0 is going to represent each character in S, right? So we're doing with S, this $sign just represents each character. Boom, 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 boom. That's what that $0 is going to represent. Now we're going to create a dictionary to count the occurrences of each 10-letter sequence. So for that, we're going to say, we could declare a variable, we could call it dict, we could set that to an array. Then we're going to say array slice, and it's going to be, so less than sign, character, greater than sign, then we're going to say colon, integer. Then we just initialize it with 2 parentheses like this. Now what this array slice is, let me just give you an example so you can know what the array slice is. Say we say let array equals an array, we can say 1, 2, 3, 4, 5, right? Boom. Then we can say let slice, the slice would be the array, boom, say we say 1 to 3, boom, right? So say we say let slice equals that, right? So the slice would be, we could just comment it out, or the slice would be or an array slice, let's just say array, let me just spell it out for y'all so y'all can see, give y'all a better visual representation, right? So that would just be, it would contain, boom, it'd just be contained, it'd be 2, 3, and 4. So say we slice this 1 through 3, that would be for index 1 through 3, so that would be these integers right here, and that would be like what the slice is. Boom. So just wanted to show y'all that. Now we need a slide. We're going to create a sliding window of size 10 across the DNA sequence. So we're going to say for offset in 0 ... DNA count minus sequence length to create our sliding window. We're going to say we're going to get the current 10 letters or 10 character sequence. We're going to say let sequence equal DNA, open up the square brackets, offset dot less than sign, offset plus sequence length, just like that. Then we're going to increment the count for this sequence in the dictionary. So for that, we could just say dict square bracket sequence comma default colon 0 plus equals 1. So each time we see this sequence, we're going to start the count from 0, but each time we see that sequence, we're going to increment the count by 1 by saying plus equals 1. Now we need to filter and return the sequences that appear more than once. So this is going to count the numbers. This is going to count how many times each sequence appears. Now we need to filter out all of the sequences that appear more than once. So for that, we come underneath this for loop and we say return dict dot keys. Come underneath that, we'll say dot filter. Clean this up a little bit for y'all. Say dot filter, open up the brackets. We're gonna say dict square bracket $0, comma default :0. Come outside of that. I want to say greater than 1. So we're going to filter out all of this, all of them that are greater than 1, or that have a count greater than 1. Then we're just going to say .map, open up the brackets. We're going to say string, open up the parentheses, $0, just like that. Now that should be all she wrote, y'all. Let's go ahead and give this a run. Oh, so what do we have here? Let me see. Cannot find offset. Oh, sorry, y'all. That says off. I don't know what that just said. But let's go ahead and run it again. See, make sure it runs this time. And it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Okay, 79 milliseconds beats 49.46% of users with Swift. We could definitely get those numbers up, but for now, I feel like this is a good solution that we all can learn from. It's easy to understand. You could learn a lot from it just because you can understand what's going on here. So that's why I want to pick this solution so that we can use what we learned in future solutions. So with that being said, y'all, get one more look at the code. And yeah, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.